Alright, this is another example of taking the derivative of a parametric equation. This time I want to find the second derivative of y with respect to x. So I'm going to start the same way by taking the derivative of each of these functions with respect to t. dx dt is equal to, if this was just t to the 1/2, it'd be t to the, or 1/2 t to the negative 1/2. So write it as 1 over 2 square root t. And then dy dt, this part of the derivative will go away because there's no t in it, so I just have to take this part and it'll be, bring down the to a 1/2 t. Okay, now I want to find dy dx, just the first derivative, and I do that by dividing the derivative of y with respect to t by the derivative of x with respect to t. So the 't's are going to cancel each other out. Don't have to worry about them, so I'm just going to put t over square root of t. So I'll put dy dx is equal to this thing, t divided by, but it's actually going to be t to the 3/2, because this will be, when I divide, this will go up top also. T to the 3/2. Now to find the second derivative, I take the derivative of this with respect to t and then divide by this again, or dx dt again. So first I'm going to take the derivative of this, so d dt of dy dx is equal to, so I just bring this down, so I'll have 3/2 t to the 1/2, okay, and so that's equal to, and then on the bottom I just have this again, so dx dt. So to write d2 y dx squared, I take this thing and put it on top, and then I divide it by the dx dt again. So I have 3/2 t to the 1/2, 3/2 t to the 1/2, divided by, then this 1 over the square root, or 1 over 2 square roots of t. So 2 square roots of t. I'm going to copy dot flip with this thing, so that'll be over 1, and it'll be 2 square roots of t. So t, this cancels this out. So that means that when this will cancel with this, I'll have 3t. So that was fairly simple in the end. The second derivative with respect to y, or the second derivative of y with respect to x, is equal to 3t. So I took the derivative, each of them with respect to t, and then I arranged them into dy dx. Once I had dy dx, I took the derivative of that function with respect to t. That became the numerator, and then the denominator is dx dt. Again, the derivative with respect to t of the variable that goes in the denominator. So then once I did that, I simplified them, and here is the answer. Thank you, and let me know what you want to see next.